discuss the code part. So first of all, we upload and extract the training data. So here we upload our training data and then we extract the zip file into the folder so that we can read the training file later. And then here we upload and extract the test data similarly as of the training data. And then we check the files in the working directory, and that is to simply list all the files and folders which are in the current working directory. And then we load the training data. That is, here we define all the 43 columns we have, and then it helps us to confirm that the uploaded and extracted files are present. So now that is, we display the five rows of our training data set. And here we can see the data set head part. And then after that, we load the training data set. And then similarly, we do it for verifying the test data extraction. Again, we give the 43 column name of NSL-KDD dataset. Then we load the a file into the pandas data frame here, and then we print the data set, which is the training data set and test data set. And now here, that is the encoding part. That is, here we convert the attack label for binary classification. We convert the attack label into binary one, that is normal into 0, and if any attack occur, then we give it into 1. Okay. And then here we give X with all the features and Y for the binary label. Similarly for the test also. And then we just do the sprint all the training label distribution and testing label distribution. Okay, and here in this code cell, we are just printing the normal and attack sample. Based on the normal and attack sample, we just display the encoded values. We just show a few rows of the encoded categorical column to confirm if they were converted successfully. That is both of the train and test set. We just check them here, and then here we just do scaling. That is, we all know that the machine learning models work better when all the features are on a similar range. So here we are applying standard scalar function. So this function helps us to normalize the feature range. That is by fitting the scaling on the training data, and we apply scaling to both the training and test data by improving the model performance. So the scaling is important part which helps us to improve the model performance. And this is how we build a stacked ensemble model. This is the main part, main code part. So here we create ensemble model using, okay, here we have a meta learner and also a base learner. So this is how we define a base learner. So here we use random forest classifier, SVM and KNN as base learner, and also we use logistic regression as meta learner. And then Here we are creating a stacked ensemble model with a cross validation value as 3. And stacking helps us to combine the strength of the multiple algorithms. So these 3 algorithms here we mentioned, we will just combine all this and strengthen using combination of this multiple algorithms. So after that, we just train the model. We just give the trained data set, which is scaled one, into the model. We will fit the model using fit function, and the stacked model is used training using training data, and after that we predict. So here this is the predict function. We give the test data set here, which is a scaled one, which is we give into the y underscore prediction. And then in this cell, we can see that we are evaluating the model. That is, it shows the overall performance here. We know that the classification report include precision, recall, F1 score, and support. So this helps us to identify the attack and normal traffic. So here we can find the accuracy of our ensemble model. That is, we achieved a 0.7859 accuracy, which is 78% accuracy. And then we plot the confusion matrix. We generate a confusion matrix here by showing the true normal, true attract, false normal, and false attack. This gives us a clear visual of a model correctness and error. So, when coming to this cell, here we compare the base learner by using cross validation with cross validation. We also do cross validation here. We run a threefold cross validation. Here we can see that we have given a threefold cross validation. It is CV equal to 3. And also we compare all the base learners here. We need to know which of the model and which of the accuracy is. Here we can see that a random forest model gives 99% accuracy, and the linear SVM gives 95%, and KNN also gives a 99% of accuracy. That is, we here we print the individual accuracy of the different base learners. Okay, and then here we print the feature importance, and then we save the model in the cell. Okay, so the random forest to identify the most 10 features, important features of our dataset. We use random forest classifier. So the feature importance from data random forest, we give random forest classifier, the random state, and then we fit the model. And then we print out the 10 feature by importance, and then we plot it using my plot function. And here we plot their importance. We save this trained stack model. Okay, we can see it here that we save the model, which is the trained stacked model. At last, we save it so that it can be easier to later. We do not need retraining the model. So this is the plot which shows the each of the features and the importance of features based on the random forest classifier. So that's it. Thank you.